Therefore, negative feedback loops responds in order to get back to stability. When there is too much of one thing, the body does its best to decrease until the equilibrium is reached. If there is not enough, the system will increase the amount so it will be stabilized again. Positive feedback amplifies the starting signal. Positive feedback is usually found in processes that need to be pushed to completion, not when the status needs to be maintained. For example, a process of labor and childbirth is an example of stimulus in positive feedback loop. Sensors like nerve cells in the cervix detect pressure placed on it from the head of the fetus during labor. Nerve impulses from a sensor will travel to the control center. The pituitary gland, located near the brain, is the control center in many feedback loops. It produces many different hormones such as oxytocin. Oxytocin is a hormone that stimulates uterine contractions, helping the baby move. Because of the signals of the control center, the mother's body produces more and more oxytocin, allowing the uterine to contract more. This positive feedback loop continues until the baby is born. Other example of positive feedback is digestion, where stomach uses the molecule pepsin to digest protein. When food is taken into the body and needs to be digested, pepsinogen, an enzyme in an inactive form, is converted to pepsin. The conversion triggers a positive feedback as other pepsinogen molecules in the stomach to pepsin, so that the stomach accumulates enough to it to be able to digest proteins. Another example is blood clotting. When a part of the body is injured, it releases chemicals that activate blood platelets. Platelets are responsible for stopping bleeding by forming clots. An activated platelet in turn activates more platelets, which groups together to form a blood clot.
Created using Powtoon.